All right, welcome 6th grade. The first few slides I'm going to go pretty quick over because we already did. From there on out, we can go a little slower or Mrs. Leifer can pause it as she needs. So, matter. Anything that has mass and takes up space. Air is matter. Animals, sports equipment, water, all right, vehicles, your desk, you, all that is matter. Elements, substances made from only one type of atom. Remember, we talked about it was like building with all the same size and color red block. That would be an element. These are the elements. They're on the very back page. We even talked about like what that 4, what that 21 meant. Okay? Then the last thing we got was the parts. We had protons. Protons are a positive charge in the nucleus, and they have weight. Then there's the neutrons. The neutron also in the nucleus, but no charge. N and N, neutron, no charge. P and P, proton positive. Both of them have weight. Then there's the electron. It is a negative charge. Don't have the N and N, it doesn't match, but oh well. It's outside the nucleus in the electron cloud. There's no weight to it. All right. Now, when we go to page 37 and look at the first paragraph, we're going to talk about two things. The atomic number. That is the number of protons in an atom. Remember, the atomic number is right above the atomic symbol. We talked about that Friday before we were gone. So, iron, Fe, the atomic number is 26. That tells me it has how many protons? Hopefully somebody said 26. Because the atomic number is the number of protons. Or the number of protons is the atomic number. All right? That's one way to look at it. Then the mass number is the number of protons plus the number of neutrons. And remember, if we rounded this number to a whole number, it'd be like 56 for the mass number. This would be 59 for the mass number. 59 and 64. The mass number is protons plus neutrons. Both things that have weight, or both things that are in the nucleus. So, atomic number, number of protons. Mass number, number of protons plus neutrons. Now, how many electrons? This will be important for your homework. In a neutral atom, that means the one with no charge. On your homework, we're going to pretend all atoms are neutral on that page. All right? The neutral atom has the same number of protons and electrons. Protons are positive, electrons are negative. If they match up and have the same number, no charge. But now, if we have one more proton than electron, so let's think about that. We got P and P and P. When we only have 1, 2 electrons. These make neutral. These make neutral. There's one left. Well, protons are positive. So that would be a positively charged ion. If there's more protons, it's a positively charged ion. Now, I bet you're pretty smart and you can think, if there's more electrons, only 1 proton and 2 electrons, if there's more electrons than protons, those make neutral. Electrons are negative. Therefore, it's a negatively charged ion. I should have had the word ion here. Okay? Negatively charged ion. Charged particles are called ions. If their number of protons and electrons is different, they're a charged particle, an ion. More protons mean positive ion. More electrons mean negative ion. Okay? Now, let's look at this. This one is a positive charge. It has more protons. Do you see how there's 2 protons? 1 electron. That means a positive charge. This one is a negative charge. 1, 2 protons, 1, 2, 3 electrons. More protons than electrons, positive ion, positive charge. More electrons than protons, negative charge, negative ion. That's a way you can remember it. All right. Isotopes get kind of confusing. They will probably take a lion's share of our time. I'm going to go quickly over it, and we'll cover it when I come back. It is in my plans. So, atoms of the same element that have different numbers of neutrons. Page 38, we're going to use the heck out of that when we get back. If you can try to figure it out on your own, amazing. If you can't, that's fine. But, here's where we go. Do isotopes have different mass numbers? Yes, because they always have the same number of protons, but their number of neutrons changes from isotope to isotope. We went quickly by that. You're probably questioning what the heck an isotope is. I understand. I'm going to get it when we come back tomorrow. But we'll do a short item here. An isotope is the same number of protons and a different number of neutrons. So all three of these are hydrogen because they have one proton. That makes them hydrogen. But this hydrogen has no neutrons. This hydrogen has one. And this hydrogen has two. We call this one hydrogen 1 because there's one thing in the nucleus. Call this hydrogen 2 because there's two things in the nucleus. We call this hydrogen 3 because there's three things in the nucleus. All right. So they all have the same number of protons, 1. They're all hydrogen. But a different number of neutrons, so they're different isotopes. Same protons, but different number of neutrons. All right. So now if we go back really quickly, which I think these are out of there, isotopes do have a different mass number. That's how we get that. But they have the same atomic number. We can see this with carbon 12 and carbon 14. Carbon 12 has 6 protons and 6 neutrons. That's how we get to 12, because there's 12 things in the nucleus. Carbon 14 has 6 protons, making it carbon, and 8 neutrons. The 8 neutrons plus the 6 protons make the 14. That's telling me the number of things in the nucleus. So same number of protons, different number of neutrons. Now we get to do my favorite and my most fun page. We will spend a lot of time on this page, and if you can figure out the homework, amazing. If not, well, we can work on this together because we'll fill this chart out one another. So, one thing we can remember is the number of protons is always the same as the atomic number. Well, this is a terrible time for my board to stop writing. All right? So, I don't know why it chose to do that right now. It looks like I lost all touch abilities. So, I guess it's telling me it's time to move along. All right. We'll jump into that again tomorrow.